Hello, my dear student. Once again, welcoming you to Vision Plus channel. Here, we teach chemistry. We teach also different subjects like math, but specifically I'm specializing in chemistry. They call me Wow Chemist, and I'll be taking you today through this formulae and also isomerism. Yes. So we are going to talk about the molecular formula, the structural formula. Then at the same time, we're going to talk about the isomer and isomerism. So we simply say when they say molecular formula, this is the formula which shows the number of atoms of each element in a compound. So molecular formula just shows for us the number of atoms. Same like I have. Okay, let's say n is equal to 3. Then that element, let's say the element is what? Let's say that element is carbon. So that means I'll have how many carbons? I'll have 3. So 1, 2, 3. So let's relate it to the alkanes we're teaching. We shall say we have single bonds here. Then also this one here, see, we are saying that when carbon is bonded to hydrogen, we call them hydrocarbons. Here we shall be in position to have hydrogen, to have hydrogen, to have hydrogen, to have also hydrogen. And here we shall have a hydrogen, we shall have a hydrogen, here we shall have a hydrogen. Now, this one is the structural formula. But we say molecular formula, what I'm explaining is that we shall be in position to see that the atoms, okay, of each element. So here we shall be in position to say 1, 2, 3, 4, 5, 6, 7, 8. So here we shall have 8 hydrogen, we have 3 carbons. So you see something like this, C, 3, then also we shall have H, 8. So this is the molecular formula. It shows the number of atoms of each element in a compound. So this is what we call the From the previous lesson, we say this one is called propanes. That means there are 3 carbon atoms. The word panes, that's why we put something like this from the word A-N-E. So that is the definition of molecular formula. In exam, we will say define molecular formula is just very simple. You be in position to say this is the formula which shows the number of atoms of each element in a given compound. So if I don't want to write this one in that format, I can also say I have C, and I'll say I have CH3, of course, I have CH2, I'll have CH3. So when you look critically, say 3 plus 2, you have 3 plus 2, we shall get 5, then plus 3, we shall get 8. So it is here. This also shows what is the molecular formula for this compound, because it is showing that we have 3 carbon atoms, 1, 2, 3, then we have 8 hydrogen atoms. So let's come to what we call the structural formula that we talk about it. It shows the atoms of elements. It shows how atoms of elements are arranged in a molecule. So let's give an example of that. Let's say ethane. Example ethane. So ethane, ether is having how many carbon atoms? It's having 2 carbon atoms. So when we want to show the structural formula of ethane, we shall be in position to say that I have 2 carbon atoms. If I have 2 carbon atoms, then they are linked by a single bond. So we can be in position to get something like this. We have something like this, something like this, something of this kind. So we have 1, 2, 3, 4, 5, 6 hydrogen. So this is the structural formula. It shows the what? It shows how atoms are really arranged. So this is the arrangement exactly. You see carbons, then you see hydrogen. This is the arrangement. So the moment you see something in that format, we are simply saying that it is called a structural formula. But also there is important things that we have to look at. Isomer. So when you say isomer or isomers, they are simply those compounds with the same molecular formula, but what? But different structural formula. That's why we first give the definition of molecular formula, then from there give the definition of structural formula. Because here we are saying that if we come to isomers, you see that these are compounds with the same molecular formula. So that means with the same number of atoms of each elements in that very compound, but also when we come to the structural formula, it's different. And we have the examples down. We shall see how different are. Then also isomerism. So isomerism is simply the existence of compounds in this format of isomers. So we shall see critically that big keen enough, they can say distinguish between isomer and what? Isomerism. So isomers, they are the compounds themselves, okay? With the same molecular formula, but different what? Structural formula. But when we say isomerism, it's now become the existence or the situation where those elements exist in that format. So we have a very good example here that we have CH3, CH2, C, then we have CH3, CH3. So I'll be in position to really show you how this thing is coming about, and we relate it to what we call isomerism. So here we have CH3, of course, we have CH2, we have CH, we have CH, sorry, then here we have a branch. We're going to talk about these branches. Then, and we have this, shall have CH3, of course, then we shall have shall have CH3, then it is close to outside, then we have CH3. Now, let's say this compound and this compound are what? Are isomers. Why? Because when we look critical, we shall say they have the same what? The same molecular formula. How? Let's count the number of hydrogen atoms here, the carbon atoms, and also here. So here we shall be in position to say carbon atoms here, carbon atoms, we shall have 1, 2, 3, 4, 5. So we have 5 number of what? Carbon atoms. How about hydrogen atoms? Hydrogen atoms, we shall see that we have 3 plus 2, 5, plus 1, we have 6, plus this we have 8, and plus this one, we shall be in position to have 11 hydrogen. We have 3 plus 3, 6, 7, 9, we have 12 hydrogen. So we shall be in position to have 12 hydrogen. Yes, then from there, we shall see that we have 5 number of carbon atoms here, then we have 12 number of hydrogen atoms. So let's see how they are isomers. So here also we shall have, let's count the number of carbon atoms. We shall have 1, 2, then we say 2 times this one carbon atom inside, we shall have 2 number of carbon atoms. So plus these 2 we have 4, plus 1 outside we have 5. So therefore, carbon atom this side also there are 5. Then let's look at the number of hydrogen atoms. We have 3 plus 3, automatically get 6. Now, these 2 will multiply what is in the bracket also. We shall have 2 times 3. This 3 is only for carbon, is only for hydrogen. So we shall say 2 times 3, we shall get 6. So I have 6 plus 6, I'll get also hydrogen atom to be 12 this side. So when we look at this critical, they have the same number, the same what? Molecular formula. So let's see how they differs in what? In their structural formula. Let's see this arrangement very careful. So here we have how many hydrogen atoms? We have 5. So we shall be in position to say 1, 2, 3, 4. But there is a branch on this carbon, so we shall have, so you have 1, 2, 3, 4, 5. Let's put the number of hydrogen atoms. And we are still in alkanes. We're saying alkanes have only a single bond between the carbon atoms. So we shall be in position to put something of this kind. So for this we shall have 1, 2, 3. Then I'll have 4. Then for this I'll be in position to put it like this. 1, 2, 3, 4. Then this one also we shall be in position to put 3 bonds here. So we shall have 1, 2, 3, 4. So let's put the number of hydrogen atom. Let's put the number of hydrogen atoms. Let's put the number of hydrogen atoms here. So this is the structural formula for this, and we are saying simply the arrangement of atoms of elements. So let's look at this one again. We shall have one, two, but there's a branch. We shall have one, two. So on this second carbon, we shall have a branch like this. Shall have a branch like this. These two in the bracket is what I'm opening up. Then it also have something like this. So we put the number of hydrogen atoms. We put the number of hydrogen atoms. We put the number of hydrogen atoms like this. So carbon is having 4 bonds throughout. If you don't see the 4 bonds, that means your chemistry is not correct. So this is the structural formula for these compounds. We're going to name them ahead, and this is the structural formula of this compound. So when we look at them structurally, their appearance, their arrangement, this one is different from this. And that's why we are saying isomers are simply compounds with the same number of what? With the same molecular formula. This is the same number of what? Atoms. Then, and with different what? Structural formulae. You are seeing very well that this compound and this compound structure, when you look at them, the arrangement of atoms of different elements are different. So that's it. That's what you have to know about isomerism. Then, when we look at the second example, I'm just going to explain it. Not so much because we have gotten the concept from there. When we look at this one carefully, we are seeing that we have how many carbon atoms here? We have 1, 2, 3, 4, 5 number of carbon atoms. Then also hydrogen, we have 3 plus 2, 5 plus 2. We have 7 plus 2, 9 plus this. We have 12. So hydrogens, we have 12 here also. Then carbon, we have 5. Now let's look at this one also. We shall have 1, 2, 3, 4, 5 with this. So carbons, we have what? We have 5. Then hydrogen, we shall have 3 plus 1. We have 4 plus 2. We have 6 plus 3. We have 9 plus this. 3 we shall have 12. So hydrogen we shall have 12. So this molecular formula is the same. Why? Because we have the same number of what? Of carbons this side and the same number of hydrogen this side. Now let's look at them structural. When we look at this thing structural, the arrangement of these atoms is completely different from the arrangement of these atoms. And we are saying that all this format we are seeing here is what we call isomerism, the existence of compounds with the same molecular formula but different structural formulae. So what you are seeing here, they are completely different. That's what you need to know about isomerism, isomers, and what? Molecular formula. So I can simply formulate questions from here. Possible questions that will come from here. We shall have question number 1. We'll be in position to say, define the following terms. So I can say it. Part A, I'll put molecular formula. You're seeing the definition already. I'll put molecular formula. Part B, I'll be in position to put structural formula. Then now, number 2, I'll be in position to say distinguish. I can say differentiate. I can say distinguish between isomers and isomerisms. You need to be keen enough here because you can easily mix up the two definitions. Then now, part 3 will be like or I can say giving examples. This part I can simply say giving examples, distinguish between isomers and isomerism. So you'll be in position to give some examples that you see they have the same molecular formula, a different structural formula. So we end here for this time. Thank you.